So we're back at it again. Our heat pump has failed. This is 1.5 tons. What's going on is it's building head pressure and going off on high head, a limit switch in here. So what I've done for the last week is, what I assume is going on is I've got some debris in front of the expansion valve. So what I do to get it working without working on it is reverse it, put it back into heating, blow that debris away from the expansion valve, and then it works for a few days. But today I'm going to try to fix it. So you look at the gauges here, we got 260 and 190, and it's been sitting here for 30 minutes, so it will not equalize. So we're going to tear into it. A contractor would probably be forced just to replace the indoor coil and expansion valve. It's the kind of the straightforward approach that gives him the best confidence of not having a return call. But since I'm a homeowner, I'm going to go and see if I can repair it. Come along with me, we'll figure out what it is. So what I'm going to do now is pump all the refrigerant down into this condenser coil. I have the fan indoor running on continuous operation. I have the liquid line closed shut. I made a few turns with the suction valve here, service valve. So what I'm going to do is push in the contactor, and I'm going to try to get, hopefully I can get through that expansion valve and get this pump down, because I don't really have much refrigerant with me. Alright, it is going to pump down, looks like. Alright, the compressor just equalized, so I'm going to back off of it and let it settle down. So the pressures are pretty much equal there. We'll keep doing the process until I get it where I feel like I have the refrigerant in the coil and not much in the lines. This liquid line filter here is a two-way. It's a 13-year-old piece of equipment, so I'm going to replace that today too. I do not think it's stopped up. I'm just going to do it as preventative maintenance. Okay, I've got all the tools that I think I need in the attic. So now we'll go take the evaporator apart. Looks like we got a lot of mold all over. So let's tear into this part of it right here and see what we can find. Okay, I had to cut the bracket off holding the expansion valve. I'm now able to get on to the expansion valve and that flare nut right there beside it. Nothing so far. Got a tank here that's very hot, been sitting out in the sun. We're going to blow refrigerant back through here and see if it unblocks here. See if I can hear something right here. Nothing coming that direction. Alright, now we're going to go in the suction through the coil and back out this. I was taking this apart and I found a refrigerant leak. See all that oil? It's either coming from this or maybe this connection right here. going to go in through the suction line. If it's in cooling, pressure will go that way and hit the service valves. Come back through, go through the evaporator coil, work its way through here, come out right here. Let's see what happens. These are called distribution tubes, and they're very small, so if there's anything blocking, it had to be right in here. Nothing there. Let's see. I need to blow through this one. We've proven that this is cleared, so I need to prove that this is clear. So I'm going to go downstairs and pump back through the 3/8 line. This is the liquid line in the cooling mode. Okay, so we've blown out this way. We've blown in through the expansion valve and out the 3/8 tubing. There's no restriction here. There's no restriction here. I've blown in through the suction valve on cooling, through the coil, through these loops, back out here. No restriction. I went down, I kept this rag on this line, and I went down and opened the service valve, or put a tank on this discharge line, and blew violently through this with the rag on it to catch something. Nothing come out. Okay, so we're clear here, we're clear there, we're clear here, and we're clear there. So the only thing that's left is this externally equalized expansion valve. So I could order another one of those, but when you look at this coil, I can see that there's been a problem here. When I look at the inside of the cabinet, can you see the mold? So what that tells me is, and I'm guessing on this, but refrigerant piles up, stacks up in this line because something is closing off. Maybe this is bad. And then the unit shuts down. It's good enough to cool the house. We got a lot of insulation in the house, you can see it. So once it shuts off, it's cooled. This line continues to have pressure in it, and it meters through here. Now it becomes like a freezer, right? The distribution tubes distribute a little bit of refrigerant all over this coil, and you can see there, because I promise you I changed my filters, and it looks like my filters have been dirty, but they've never gone without being changed, ever. And I didn't have this on during construction. So if you look at it, there's plenty of mold to suggest I got a problem here. This is not normal. This means high humidity, low airflow, but I have no problem with airflow, none whatsoever with this unit. So there's something else going on. It happens after the unit is shut down. So what I'm going to do now is put it back together and pull a vacuum on it, charge it, and hope for the best. And if it fails again, I probably will see what the cost of this coil is versus the cost of this expansion valve. The risk being, if I change this and it's something I don't understand, I still have the problem. The cheapest, most efficient way, not the cheapest, but the most efficient way would be to replace the coil if they still make it. This is only 1.5 tons right here. So we only live in 800 square feet, so don't know if they still make it. We'll find out. Okay, I got it all buttoned up. Let's go back and go back downstairs. Pressure up on the lines. Soap test all the connections. Everywhere I broke a connection, all the new ones. See if I can see the leak over here. And then we'll break that and pull a vacuum on it. Alright, we got 150 pounds on it. I have searched with soap. 150 pounds. Can't find the leak here. So it could be that when this is in heating mode and this is the hot gas line, maybe that leaks right there. It's odd though that it would leak that oil. That doesn't make sense. But so what I'm going to do now is clean this coil a little bit and then go down and pull a vacuum on this unit. There's the coil after spraying the coil cleaner on it, which is this. And I sprayed it down with water. I cleaned the coil, sprayed it down with water, and so it's going to have a chemical smell. And I sprayed the entire unit with Lysol. Alrighty, we got a little pressure, maybe 40 pounds in the system. This has been in there since, well, it's been 11 years, I guess. So you want to minimize your time if you expose the new filter to the atmosphere, because the desiccant in it will absorb all the moisture. It's going to absorb very quickly. This is an exact replacement. This goes from, I think, 1 to 3.5 tons, something like that. Exact replacement. BF083. Now, a normal conventional air conditioner, this would be directional, but this is two-way. It's got check valves in it, both ways. There's that. Sometimes you can hear a little vacuum or purge. Alright, going back in. Refrigerant's still coming out of the lines. Hear them Carolina wrens raising Cain. We'll check that for leaks now. Alright, I've got 175 pounds. No visible leaks. We're about ready to crank her back up. But first I want to check this. So this was the house side of this. Open that way. Open that way. I can't tell if that restriction that I just felt is factory. I've never taken a new one and done that, but it does blow through. So this is 13 years old, so it's a good practice to replace it. Here it comes. After about a minute, it should clear up if it's properly charged. You can also charge by superheat, which I just released the charge that was in this. So as that expansion valve starts choking off on the flow, this sight glass is going to fill. You can see it's getting the air, not air, but the gas in it is getting smaller and smaller. So when I first started it, it was flashing, then it cleared up real quickly, and now the expansion valve got a hold of the system, let's say, and it's regulating the refrigerant. to properly feel that coil. And that coil's clean. So I'm gonna go with that. I'm about to run out of daylight here. Hope you learned something. The things that would have made this better is if I'd have found some debris. Something could have come out of it and I didn't see it when I blew through there. Another thing that would have been nice if I'd had a bottle of nitrogen and a regulator. And check that for that leak upstairs. I could not find it with soap, but with nitrogen and 300 or 400 pounds, you know, probably could have found it. So I'm probably not done with this yet. We're going to see how it operates the next few days. The only thing I accomplished today is I put in a Schrader valve on the liquid line, and I verified that I was not obstructed. But yet I do know that it gets obstructed, and then it goes off on high head. And so I run out here and reverse it, clear it up, and get it going again. So anyway, hope you enjoyed the video. We're back. I have a new air handler I'm going to install today. The thermostatic expansion valve did plug up one time, and it's been months now. But because of that, I decided I didn't want to trust it anymore. And also, just this mold concerns me. So I had a problem here all along. So what I'm doing now is disconnecting the low voltage wires. And I took time to write down what each wire goes to, so I wouldn't have to figure it out. So we got the power off. I'm reclaiming the refrigerant, and I'll get back with you. We're going to use my tractor to put this up in here because it is upstairs in the attic. I carry one of these in my tool pouch. So what this does is it keeps you from having to go back down the stairs to find a meter, so you can prove you threw the right breaker. So what I did was turn on the fan, and when my wife threw the breaker, the fan quit running. So that's a pretty good indication. And this little indicator here will light up if there's power. So now I'm going to disconnect the power here, get this out. I've got the low voltage out, and we'll put this cover back on, and then I'll see where I am on the reclaim and cut these lines loose. Okay, at this point we got all the electrical disconnected. I'm ready to cut my copper pipe. Been all back in there, suspending this ductwork, the plenums, everything. So it'll be easy to slide the other one in here. See, I've got support straps holding up ductwork, and this is something I do a lot. It's better if you use metal duct, but if you put a cradle underneath your ductwork, it'll keep it from kinking over the years. If you want to see what's back here in my attic, it's pretty cool. I put this plywood everywhere so I could walk up here and ran lights. And I had those Christmas lights. That's why they're here. They're not something I recommend, but I had them, so I put them out just so I would have the ability to see in dark places. See that back in there? Alrighty, here we go. Yep, there's the blood. Always blood involved. Whoa, I never thought we'd be doing this. Let's see. You gonna hit anything?
No, not that I can tell.
Okay. It's out of the attic.
Now what?
Start it up, back it up, and get out of here. Are you scared?
Certainly don't like it.
I'm gonna go take it to the train station.
Okay.
This is 10 kW heat. This right here provides heat when your heat pump's in defrost, or when you switch your thermostat to emergency heat. When you go to emergency heat, your heat pump's locked out and all you got is this electric heat.
New unit. About to go in up there. I think it's stuck.
Try to get in there.
Be careful, please. Way too dangerous what you're doing right now.
If my granddaughter was here, she'd be helping me.
Yes, you would. She's not afraid of heights like Renona.
Yeah, I'm in. Here we go.
Go slow. About to come off the edge.
Is it?
Yeah, go nice and slow.
All right, I've been up here most of the day and some of the night now. All the copper has been sweated together, silver soldered together, and I checked for leaks with soap and water with over 100 pounds on it. So now I'm just gonna put it back together and run the fan. I won't open the valves tonight. I'm just gonna sit on it till tomorrow and see if that 100 pounds is still there. Just to recap, the heat pump was cycling on the high pressure switch, and it was apparently stopping up at the expansion valve, and you saw me clear it, or attempt to clear it, and then afterwards, I don't know, we ran a month or so, and it stopped up one more time. So at that point I decided I was going to replace the whole unit, because of the mold mainly, but also because I couldn't solve the problem. So you saw here where we installed the unit, but I also cut footage on the checking it out again outside, and my SD card failed. And so I guess I won't show you that, but it's the same old thing. Open the valves, release the refrigerant, and then check it out. Set, charged by superheat, and I got that sight glass also. So I hope y'all enjoyed this, and I hope it showed you something. It was a long, drawn-out process. A technician wouldn't have done this. You'd had to get to resolution a lot faster, but I was trying to be cheap. Anyway, hope y'all enjoyed the video, and we'll catch you on the next one.